So in this video, let's look into the solution for project number 14, that is housing project using stats models. So here, let's get started and let's start doing the hands-on coding. So I'll start by downloading the data set. So if I execute this cell, so this is going to download the data set. I have already executed this cell. So I've got my CSV file over here. Now then, what I have done right now is I've actually loaded this CSV file as a data frame and display first few entries of this data frame. See, the value column over here, it contains the median value of this owner occupied homes in the $1,000. And this is what we are trying to predict, which is our target value. The rooms and the distance column, they actually contain the average number of rooms per dwelling and the weighted distance to 5 Boston employment centers. Both are my predictors. So to sum it up, here we are interested in predicting the home values based on the number of rooms of a home and its respective distance to the employment centers. So this is what we are trying to do right here. So this original data set, that is the Boston housing data set, is available inside this scikit-learn library. But just to ensure that we are working and we have actually simplified this to ensure that we are able to implement our very first linear regression model. Okay. So as I mentioned at the beginning of this video, we are going to apply the linear regression model with stats models. Now this stats models is actually a module which helps us to conduct the statistical test and estimate the models. So here it actually provides an extensive list of results for each estimator. Now by default, when you start working with this Anaconda interface or Google Colab, you already have stats models installed. Now in this example, I'm going to say pip install stats models. So this is going to install the stats models for my Google Colab interface. So here I can see the confirmation that says as requirement already satisfied. Now once you have installed this stats model, so we are going to import it. The way that we are going to import it is, so I would say that import stats models dot API as SM. Then the first thing that you have to do before creating a linear regression is to define the dependent and the independent variables. Now in this example, we have already discussed them in the start of this video. So the dependent variable is actually the value that we want to predict, and it is also known as a target value. On the other hand, the independent variables is my predictor. Now in this data set, we actually have two predictors. So we can use any or both of them in order to perform the analysis, that is linear regression analysis for this given data set. So first thing what we are going to do is we are going to implement a simple linear regression. Now when I say simple linear regression, a simple linear regression estimates the relationship between one independent variable and one dependent variable. Now for this example, I'm going to choose the rooms as our predictor, that is my independent variable, and for my independent variable, I'm going to choose it as the rooms, and the dependent variable, I'm going to choose it as the value. So I'm going to define it the X and Y like this. I would say df Boston, and then here the rooms is my independent variable, then Y is equal to df Boston and the column of the value. So this is my dependent. Okay, so we have represented the dependent and the independent variables with the help of Y and X respectively. Now once we have defined and separated this X and Y, so here we have to perform the fit for a given data set. Now if I want to explain what exactly the fit is going to mean, let's consider an example. I know we have discussed in depth in our previous sections, but if I want to give you an overall idea, a simple linear regression is containing one independent variable and one dependent variable, and the relationship between X and Y is given by the equation y is equal to ax plus b. That means for the given set of data points, we are trying to predict a straight line which passes through most of the data points. And we are interested in equation of this line such that most of the data points would lie or would pass through these specific line that we are creating. So that is what the finding the linear regression equation would mean. It's like finding the values of the parameters a and b so that we are going to get the best data, that is we are going to get the best line which passes through most of the data points. Okay, now in order to perform this activity, that is finding the parameters a and b with the help of stats models, first we have to add a constant before fitting a model. Now, in case if you are working with scikit-learn library, it is going to add it by default. But since we are working with stats models, we have to add it manually, and then we have to fit the model using the fit method. So I'm going to write my x is equal to sm dot add underscore constant, and I'll mention my x. Okay, so this is going to add a constant for my x. Then I'm going to apply this linear regression model. I'm going to say that same dot OLS, that is ordinary least squares, and we'll specify y and x, and then on top of this we are going to call the fit method. Now here I have mentioned as LM represents the linear model. So this actually represents my fitted model. Okay, and here this variable helps us to predict our target value. Now once I execute this, this is going to find the equation of the line by finding the values of the parameters, that is a and b, for the given simple linear regression equation. Once we have performed the fit, we can then use this variable to predict the target value. For example, I can now say that linear model dot predict and mention my data x again, and this will help me to generate the prediction. So here this code have actually predicted, yes, this has actually predicted the home value based on the data which is present inside my room column. So even though we can predict these target values from the given data set, the linear regression analysis is not completed yet. We have to know how this linear regression model that we have developed is performing on a given data set. So in order to do this, we can make use of the regression table. So this table provides an extensive list of results which reveals as how good or how bad is our model is. Now in order to get the regression table, I'm just going to say that lm.summary, and this is going to give me the regression table. So this is how the table output would look like. We've got various information in this table, as you can clearly see. So this table is titled as OLS regression results. So here OLS stands for ordinary least squares, and this is the most common method that we use it to estimate the linear regression. Now if I want to highlight some of the important results in this first and the second table, so we have something called as dependent variable. The dependent variable is mentioned as value. So this is my dependent variable, and we have something called as r squared. Now this r squared takes a value from 0 to 1. So r squared value which are closer to 0 correspond to a regression that explains none of the variability of the given data, where the values which are closer to 1 correspond to a regression which explains the entire variability that we have got in the data set. Now in this example, we have got the r squared that says that 0.484, which is nothing but 48.4%. So it means that the number of rooms explains 48.4% of variability in my house value. So that is what this r square is telling us. And then the another important one which I want to highlight is the coefficient. So here coefficients refers to the A and B which we have seen in the model equation before. And then we have something called as standard error. So this standard error represents the accuracy of the prediction. The lower the standard error, the better will be the prediction. And then we have something called as T and P greater than T. So which is actually my P value. So here it represents the t-scores and the p-values which we actually use it for hypothesis test. So the room variable that we have got, so this room variable has a statistically significant p-value, and that is what we observe in this given data set. And we can also say that 95 percentile confidence level that the value of rooms is actually between 8.279 and 9.925. So that is what we can observe from this given table. So from this table, I can say that the coefficients are actually given by 9.1021 and minus 34.6706. Okay, so these are the coefficients which will help me to create a linear equation. So I can say that this linear equation is given by y is equal to ax plus b. In other words, if I substitute the value, my y pred is given by 9.1021 multiplied with x rooms, okay, minus 34.6706. So if I execute this, see, this has generated the y pred. So y pred is also known as y hat, which is nothing but the predicted value of y. Now once I have this prediction, we can then go ahead and create an equation and create a plot as well. So I'll start by importing the matplotlib library, and then I'm going to import a Seaborn as well. So once I do the import, I'm going to say sns dot scatter plot, and here I'm going to mention my x as x rooms, okay, and y is equal to y. Then I'm going to say that sns dot line plot, and here my x is equal to x rooms, okay, my y is equal to y pred, and I'll use my color as red. Finally plt dot show. So this will help me to create a scatter plot. So let's see right now. See, this is how my data points would look like. So the blue ones displays my data points and the red line represents my regression line. So this red plot is the linear regression which we have built using Python programming language. So we can say that this is the line that best fits the blue data points. So what we have done right now is we have just built our very first simple linear regression model using the stat models library. Now let's go ahead and perform the multiple linear regression as well. So if I say multiple linear regression, so multiple linear regression is obviously made up of more than one feature and a single target variable. So df Boston dot drop, and I'm going to drop the column of the value, okay, and then I'm going to separate my y as df Boston, and then I'm going to get the value of I'm going to get this value from this data frame which will be my target variable. Now I'll just go ahead and add a constant value, so sm dot add underscore constant, and I'll mention my data x. Then linear model is equal to statsmodels.ols, then y comma x dot fit. So this will perform the fit for this given data. Now let's look into the summary right now. So if I now display the regression table, this is how the regression table would look like. the dependent variable is value. Now this time the r squared value is 0.496, which means the r squared value have increased a little bit. And also there is another line over here in this table, that is the value which represents the coefficients for the distance parameter or the distance variable. So the analysis of this table is very similar to what you have seen for simple linear regression. But obviously, if you have any further questions, team, you can let me know in the questions and answers tab that we have got in your learning management system of Udemy or wherever you're learning right now. Okay, so moving on, we have now displayed the summary and we can now go ahead and generate the prediction as well. So lm.predict, and we can send in the data x, and this will help me to generate the prediction as well. All right, guys. So just to let you know one more information before I end this video. So we have not performed the splitting of the data set into training set and the test set. Because of the sake of simplicity, we have not actually performed it. So whenever we are building any model, so it's a common practice to split the data in order to avoid the overfitting. Okay, so since this is a practice activity, just to keep it simple, I have not performed the split between training set and the test set. So I hope you guys have enjoyed it. So with this, we come to the end of this video. Now, as you progress in your learning journey, in the next video, we are going to get started with the project number 15, which is about the salary prediction. So I'll see you in the next video. Hey everyone, in this video, let's look into the expectation for project number 15, which is about salary prediction. So let's start by understanding the overall data set that we are going to work with in this given task. So this data set contains two columns. One is the year of experience, which represents the employee's years of experience. And the second column is salary, which represents the salary earned by an employee. So with this data set, the expectation from the learner is you'll have to start by loading the data set, and you have to perform the initial analysis on this data set by checking for null values, split the data set for training and the test data set. Now implement the linear regression model without using the scikit-learn, perform the prediction on the test data, evaluate the model, train the model using the sklearn library, and at the end predict the salary on the test data, and finally evaluate the model on the test data. Okay, now this is how my data set would look like. So this is the data set CSV file. So we've got a years experience column and the salary column. So we are trying to build the regression model. So we are trying to estimate the salary on the basis of years of experience. So this is a simple linear regression problem. So with this, we come to the end of this video. Now I want you to try implementing the linear regression model without using the sklearn library, that is scikit-learn library, and see how you can solve this in a hands-on manner. So I'll see you in the next video where we look into the solution on this project number 15. So see you next time. In this video, let's look into the solution for project number 15, which is salary prediction. So let's get started, and let's start by coding. I'll then switch back to the Google Colab. So first thing is we need the data. So this is going to download the data set. Now once the data set is downloaded, now here in this given data set, we've got two columns. One is years experience and the other column is the salary column. Now here the expectation is you have to train a simple linear regression model without using sklearn, that is scikit-learn library. So let's go ahead and do the same right now. We already have the data. I'll start by reading this data as a data frame. So I'm going to say pandas as pd, and then df is equal to pd dot read underscore csv. And here I have mentioned my salary data dot csv. And I'll display the first few entries of this data frame. So this is how the first few entries of my data frame would look like. Now let's check whether we have any null values or not. So df.isNull.sum. So this will help me to check whether we have any null entries in our data frame. Obviously, by looking at this output, we can say that there are no missing entries in this data frame. Now, if I describe the shape, we have got 30 rows and 2 columns. Now, what I'm going to do right now is we are going to divide the data set into two parts, that is training set and the test set. But before that, I'm going to separate my dependent variable and the independent variable from the data frame. So I'm going to say my x is equal to df, and I'm going to extract the column of years experience. And for y, I'm going to set the column of the salary. Okay, in this way, I'll separate my x and y from this given data set. Next, from sklearn.model underscore selection, I'm going to import train test split. Now here, during the split, I'm going to keep 10% of the data for testing, and I'll keep remaining data for training purpose. So xtrain comma xtest, ytrain comma ytest is equal to train test split x comma y comma test size is equal to 0.1. Then I'll also specify the random state. So this will help me to set it for the repeatability. Next, I'm going to describe the shape of my xtrain, and I'll also describe the shape of my xtest. So we have split the data into two parts. Okay, we've got 27 rows for training and 3 rows for testing. So this is how our data set would look like. Now, the next thing that we are going to do is we are going to implement the linear regression without using the scikit-learn library. Now, in order to do this activity, first thing that I'm going to do is I'm going to write a function. So this function is used to find the value of y-intercept and the slope value. Because this is a simple linear regression, I've got one feature and one target. So during the implementation, I'm going to define my function as def coefficient estimate. This is the function name that I'm going to specify, and this will take my x and y. First, I'm going to get the number of my data size, so which is given by np.size and the input data x. Next, I'm going to calculate the mean. So x mean is equal to np.mean of x. Next, I'm going to calculate the mean of y, so which is given by np.mean of y. Next, the activity that I'm going to do is I'll say ss underscore xy. This is equal to np.sum of y times x, okay, minus n times y mean multiplied with x mean. Okay, this is how I would specify. So one more thing that we have to do is I also have to import my NumPy library as well. Next, I'm going to write it like this: ss underscore xx. This is given by np.sum of x times x minus n times x underscore mean multiplied with x underscore mean. Now, in order to find the value of regression coefficient, I'm going to say that the value of, let's say, I'll call it as w, okay, which is my slope. My w is given by ss underscore xy divided by ss underscore xx. So this is going to return the value of w, that is my slope. Next, in order to get the value of c, I'm going to write it like this. I'll say c is equal to y mean minus w times x underscore mean. Okay, now once I find this value, I'm going to return the value of y-intercept, that is c, and w, that is my slope value. So if I execute this, this function has been created. Now, next thing that I'm going to do is I'm going to change the shape of my input, because here in this given scenario, I repeat. So next thing that I'm going to do is I'm going to call this function, that is coefficient estimation function. So coefficient estimate, I'll mention the value of my x train, comma, y train. So if I execute this, see, this has returned me the value of the estimated coefficients. The value of C is given by 25839, and the value of W, that is my slope, is given by 9409.43. So we have generated the prediction on this given data, that is the coefficient prediction on this given data. Now, once we have the estimated coefficients, the next thing that we can do is we can go ahead and evaluate the model. So this time I'm going to write it something like this. I'm going to store it in the variables C, W is equal to, I'll call this thing. Okay, this will return me the values of C and W. Now, in order to generate the prediction, so ypred is equal to, I'm going to say W times X test, okay, plus C. Okay, this is going to generate the value of my ypred. Now, once I have the value of ypred, we can perform the evaluation on the test data. So I'm going to say that from sklearn dot metrics, I'm going to import r2 underscore score. Next, r2 underscore score, I'll specify the value of ytest and the ypred. Now, once I execute this, the R2 score for our given model on this test data is 0.8936. Now, let's calculate the mean squared error. So, from sklearn.metrics, I'm going to import mean squared error. And here, I'm going to call this mean squared error. And I'll specify the value of my y test and my ypred. So the mean squared error is 48509442. So this is the value of my mean squared error for this given data. So what we have done in this video is we have downloaded the data set and we have found the value of coefficients without using the scikit-learn library. And then we have predicted the value of y for a test data, and we have generated the evaluation metrics, that is R2 score and the mean squared error on this test data. So from this R2 score, I can say that the features can explain close to 90% of variance that we have got in this data set. So that is what we can observe from this R2 score. So with this, we come to the end of this video. As you progress in the upcoming video journey, you're going to learn about the house price prediction, which is a project number 16. So I'll see you in the next video. In this video, let's look into the expectation of this project number 16, which is a house price prediction. So let's get started, and let's start by understanding the overall data set that we are going to work with in this project number 16. Now in this project number 16, this data set contains 9 columns. The columns are longitude, latitude, housing mean, age, total rooms, total bedrooms, population, household, median income, and median house value. So these are the 9 columns that we have got in this data set. Now here, the last column, that is median house value, this actually represents the median house value for households within a specific block. Now this is my target variable. Now the remaining columns that you have got in this data set, so these are actually my features, which is my independent variable. So the expectation is we have to apply a linear regression model. Now this time the type of linear regression model is the multiple linear regression model because I've got more than one feature. So we want to apply this multiple linear regression model on this given data set. And if I want to completely describe the expectation from the learner on this specific project number 16, first you have to load the data, check its shape, check for null values, split the data set into two parts, train the model using scikit-learn library, predict the prices on test data set and evaluate the model, find the coefficient and the intercepts using the trained model. Now, this is the dataset link. If I open that link, this is how my dataset would look like. We've got various columns, latitude, longitude, mean, age, total rooms, and this column is my target column. So the expectation is we have to apply the multiple linear regression equation. So let's get started and let's look into the solution of this project number 16 in the next video. In this video, let's look into the solution for project number 16, that is house price prediction. So let's get started and let's start coding. I'll switch back to my Google Colab. Okay, I'm now in my Google Colab. I'll start by downloading the data set. So this is going to download the necessary data set from my Google Drive, and from there we are going to get started in hands-on implementation for this given data set. I repeat, from there, we are going to begin the hands-on implementation for this given data set. Okay, now this data set that we have got, it's a California housing data set. Now here the expectation is based on the given parameters of the house, we have to predict its price. Now let's load this data set as a data frame and display first few entries of the same. I'll start by importing the pandas library. And then I'm going to read this CSV file. And this is how my first few entries of my data frame would look like. So we've got total of 9 features. We've got longitude, which is the measure of how far west a house is. And we have the latitude, which is a measure of how far north a particular house is. And we have the housing median age, which is nothing but the median age of house within a block. Total rooms refer to the total number of rooms within a block. Total bedrooms refer to the total number of bedrooms within a block. Population refers to total number of people residing within a block. Households refer to total number of households, which is a group of people residing within a home unit for a specific block. Median income refers to median income of household within a block of houses. And at the end, we have a median house value, which is referring to a median house value for households within a specific block. So this is a given data set. So we have loaded this data set as a data frame. Now the expectation is we have to train the linear regression model. Now before that, let's see what is the shape of this data frame. So if I describe the shape of this data frame, it is 17,000, 9. That means I've got 17,000 rows and 9 columns in this given data set. Now out of this 9 columns, 1 column will be my output column and remaining 8 columns will be my inputs. Next, df.isNull.sum. This will help me to display and check whether we have any null values in our data set. So as we can clearly see from the output, we do not have any null values in this given data set. So we can move forward in order to perform the prediction. Next, what I'm going to do is I'm going to split this data set into 2 parts. So one as a training data and the another part as a test data. So in order to split it, I'm going to import this train test split function from sklearn.model_selection. I'm going to import train test split function xtrain, xtest, ytrain, ytest is equal to train test split, and we'll mention x and y. Okay, and we'll specify the test size as 0.2 and random state is equal to 42. So this will split the data set into 2 parts. Okay, so yes, it says my x and y are not defined. So let's do one thing. Let me just separate my x and y. So I'll create my x by dropping the column of the median house value. So x will contain only the features and my y will contain the. So this is going to split the data set into two parts. Now, once we split the data, we can directly go ahead and import the linear regression model. So this time there is no restriction. We can straight away go ahead and import the linear regression model from scikit-learn library and perform the fit on this data set. From sklearn linear underscore model, I'm going to import linear regression. Then I'm going to say linear regression. So this is an object that I'm going to create it. Then we will say lm.fit xtrain comma ytrain, and once we perform the fit, we will go ahead and generate the prediction. So this time I'll generate the prediction for test data. Now in order to perform the evaluation on the test data, from sklearn.metrics I'm going to import R2 score, then mean absolute error. Then let's display the R2 score. So I'm going to say like this. So R2 score, and inside the parenthesis we'll specify our y test and y pred. In the same way, we are going to calculate the mean absolute error. So we have the value of R2 score as 0.6636 and the mean absolute error is 49983.58. Okay, so this is the evaluation on the test data. Now at the end, let's go ahead and display the coefficients and the intercept of this trained model. So the coefficients is given by model.coef underscore. This will be my coefficient and my intercept is lm.intercept. So this is the value of my intercept. So these are the overall parameters of this linear regression model. All right. So with this, we come to the end of this video. So we have performed this task in a hands-on manner, that is the implementation of linear regression model on this housing data set. So as we progress in the next video, we will get started and we will start working on the new project, that is medical cost prediction. So we'll look into the problem statement in the next video. So I'll see you next time. In this video, let's look into the expectation of this project number 17, that is medical cost prediction. So here, as part of this project number 17, we have been given with the data set. Now this data set contains 7 columns. Age refers to the age of primary beneficiary. Sex refers to the gender of primary beneficiary. It could be male or female. BMI refers to body mass index. Children refers to number of children covered by health insurance or the number of dependents. Smoker refers to whether the person smokes or not. Region refers to the beneficiary's residential area in the US, which is northwest, southeast, southwest, or northwest. Okay, and we have the final column, that is charges column, refers to the individual medical cost billed by health insurance. Now using this data set, you have to first load this data as a data frame and display its overall information. Now as you start analyzing, you have to convert the categorical data into a numerical data. Finally, you have to perform the training of this machine learning model, display the parameters of the model, and predict the values and evaluate the model on the test data. Now here, this is the dataset link. If I open the dataset link, this is how the structure of the data frame would look like. We've got the age column, which is numerical in nature, the sex column, which is categorical in nature, smoker, which is a categorical, region, which is a categorical. The remaining column, that is BMI, children, and charges, these are all numerical in nature. So this is how our data set would look like. So go ahead and perform this activity by implementing the linear regression model for this given data set. So I'll see you in the next video where we look into the solution for this project number 17. So see you next time. Hey everyone, welcome back. Now in this video, let's look into the solution for project number 17. I repeat, hey everyone, welcome back. Now in this video, we'll look into the solution for project number 17, that is medical cost prediction. So let's get started and let's start coding. So I'll come back to my Google Colab. First thing is we have to download the data set. So I'll just execute this cell. So this is going to download the data set from my Google Drive. Now in this data set, we actually have total of 7 columns. So I'll start by importing my pandas library and I'll read this file as a data frame. Import pandas as pd. Then I'm going to say that df it is equal to pd.read_csv and the file name is medical cost. So medical cost.csv. And if I display first few entries of this data frame, okay, so this is how my data set look like. Now I'll start by checking whether we have any null values in this given data set. So df.isNull.sum. So this will help me to check whether we have any null values. Clearly we do not have any null values in this given data set. Now let me display the shape of this data frame. The shape is 1338,7 and I'll call the info method on this data frame. And this is going to display the information about my data frame. So this will give me the information as what is the name of column, what is the data type of that particular column, and how many number of entries that we have got in each column. And along with that, it also displays about the memory usage and the data type summary as well. This is what we observe in this given output. Now, while working, we cannot use this categorical data as it is on the linear regression model. So what we have to do is we have to convert these categorical data into a numerical format. And one way that we can do it is with the help of one hot encoder. Now in order to perform this one hot encoding, I'll begin by importing the same. So from sklearn.preprocessing, I'm going to import one hot encoder. Okay. Next, I'm going to say OHE is equal to one hot encoder. Then, once that is done, what I'm going to do is I'm just going to say it like this. I'll say df.select_dtypes. Okay. Now here I'm going to mention include is equal to object. Okay, this is how I would specify right here. I would say include is equal to object. Now if I display my D, that is my data frame, this is how my data frame would look like. So this data frame D contains only the categorical data. Now on this categorical data, I can go ahead and apply this one hot encoding. So I would say encoded labels is equal to one hot encoder dot fit underscore transform, and then I'm going to apply this D. So if I execute this and display my one encoded labels, so this will return me in the format of a sparse matrix. Now I'm going to convert it into a dense matrix by calling the toArray method. So this is going to return me in the format of dense matrix. Now I'll just go ahead and create it as a data frame. So df encoded is equal to pd dot data frame, and I'm going to say encoded labels. Okay, this is my encoded labels, and along with that I'm going to just specify the columns if we would require. I'll just keep it as it is for now. Okay, so this is another data frame that we have generated, where we have the categorical data represented in the format of one hot encoding. Now once that is done, I'll go ahead and remove the original columns in my original data frame, that is df.drop, and I'm going to drop the columns, that is the categorical columns. So I would say columns is equal to d.columns. Okay, and I'll also say in place is equal to true. This is going to drop the columns in my data frame. Next, I'm going to concatenate these two data frames. So pd.concat. Here, my data frame is df encoded with my df data frame. I would say ignore underscore index is equal to true. And while performing the concatenation, perform the concatenation along the axis is equal to 1. So in this way, I'm going to combine both the data frames into a single data frame. And once that is done, we now have 12 columns in this df1. Now let's separate the input and output. I'm going to say my x is equal to df1 dot drop. The column that I want to select is the last column. Okay, df1 dot columns. So what I'm going to do is, since we have to separate the last column, so df1, and I would say iloc, that is my index position. So I'm going to exclude the last column. And for y, I'm just going to mention like this. I would say y is equal to df1 dot iloc, and I'll only select the last column, that is -1. So this will help me to separate the x and y from this given data set. Then we'll perform the split from sklearn dot model underscore selection. I'm going to import train test split. Then we'll split the data into two parts: xtrain xtest, ytrain ytest is equal to train test split. We'll specify x and y, and test size is equal to 0.1, and random underscore state is equal to 42. Next, we'll initialize the model. So lm is equal to linear regression. So before that, we have to import the same from sklearn dot linear underscore model, import linear regression. Now once we initialize the model, we can go ahead and perform the fit. lm.fit xtrain comma ytrain. So once we perform the fit, we can go ahead and display the model coefficients. So model coefficients is given by, this is the complete list of coefficients, and intercept, this is the value of intercept. Importantly, we are interested in evaluating the model on the test data set. So from sklearn dot metrics, I'm going to import R2 score and mean squared error. Ypred is equal to lm dot predict. I'll specify my x test. Now on this ypred, I'll go ahead and find the value of R2 score. So print R2 score is R2 score and then ytest comma ypred. Okay, then mean squared error, and I'll display this mean squared error. So R2 score is 0.766 and the mean squared error is 322,75850. So this is how the overall prediction evaluation would look like on this given test data. So from this R2 score, it's clear that the features that we have got can explain close to 77%, yes, close to 77% of the variance that we have got on this data set. Okay, so that is what we observe over here in this given output. So with this, we come to the end of this video. As you progress in the upcoming video journey, we will get started with the new project, that is project number 18, which is company profit prediction. So I'll see you in the next video. In this video, let's look into the expectations from the learner on the project name. I repeat. Now in this video, let's look into the expectation from the learner on this project number 18, which is about company profit prediction. So here in this project number 18, you have been given with the data set, and this data set contains 5 columns. The first column is R&D spend, that is the expenditure in research and development. The second column contains information about the administration, that is the spend in administration department. And the third column is about marketing spend. Fourth column is about the state, that is in which state the company belongs to. And the fifth column refers to the profit, that is the profit made by the company. Now here, the expectation from the learner is you have to first load the data and check its shape, and you also have to check for null values in this given data set. Now, once that is done, convert the categorical feature into a numerical format, then perform the k-fold cross validation, train the model using sklearn library, and also fit the intercept and the coefficient from the trained model. And as you progress, you have to predict the profit of the test data and finally evaluate the model and plot the predicted profit and the actual profit from the test data with reference to the R&D spend. So this is the expectation from the learner. Now the data set link is this. Now if I open this data set, so this is how my data set would look like. So as you can clearly observe, we've got almost all the columns which are categorical in nature except the state column. So state column is actually present in categorical format. I repeat, as you can clearly observe, all the columns that we have got are in numerical in nature except the state column. So this is what we observe in this given data set. Since the task is about predicting the profit, since profit being the numerical value, so we can say that we have to apply the linear regression model. All right, team. So I'll see you in the next video where we are going to implement a solution for this problem statement. So I'll see you next time. In this video, let's look into the solution for project number 18, which is about company profit prediction. So let's start by implementing it in an hands-on manner. I'll come to my Google Colab. So let's start coding. I'll begin by downloading the data set. So this is going to download the data set for us. Now once the data set is downloaded, we'll load this data set as a data frame and we'll begin our analysis as we have done in our previous projects. So import pandas as pd and df is equal to pd.read, and we will specify the file name, that is 50startups.csv, and then we will display first few entries of this data frame. Now this is how the first few entries of this data frame. So let's check the information of this data frame. So we can clearly observe that we have got 50 rows in each and every column, which means we do not have any missing values in this data frame. Now the total number of rows that we have got is 50, and the number of columns that I've got over here is 5. So we can get the overall analysis by displaying the information of my data frame. So in this example, the state column that we have got, so this state column contains the categorical data. So this time, let's convert this categorical data into a numerical format. Now in order to do this, I'm going to apply the label encoder. So label encoder is one such approach we can use it to convert the categorical data into a numerical format. So from sklearn dot pre-processing, I'm going to import the label encoder. So LE is equal to label encoder. Okay. Next, what I'll do is on this column of state, okay, I'm going to apply this label encoder. So LE dot fit underscore transform, and I'm going to apply this column of state. Now once this is done, so we'll display first few entries of this data frame. Then this is how the first few entries of this data frame would look like. Next, I'll separate my x and y, df.drop, and the column that I want to drop is the profit column. My y is the df profit. So I'll separate my x and y. Next, we are going to split the data set into two parts. So xtrain, xtest, comma, ytrain, comma, ytest is equal to train, test, split. We'll specify x and y, and test size is equal to 0.2, and random underscore state is equal to 2. Okay, so let me first import the same from sklearn dot model underscore selection train test split. Now once the split is done, it's the same thing, guys, but this time the expectation is we have to make use of k-fold cross validation technique. So this time I'm going to say model is equal to linear regression. Let me import as well from sklearn dot linear underscore models. I'll import linear regression. Next, from sklearn dot metrics, I'm going to import R2 score. Next, from sklearn dot model underscore selection, we will import cross validation score as well as k. Now once I import the model, I'm going to get the value of cross validation score by calling this cross val score, and inside the parenthesis I'll specify the value of model, that is my model instance, x and y, and we also have to mention the cross validation. So for cross validation parameter, I'm going to initialize the k-fold, so-called, and I'll use my number of splits as actually 4. Okay, so I'll mention my CV is equal to k-fold. Then I will use the scoring. Scoring is equal to negative root mean squared error. That's one scoring that I'm going to use, and at the end I'm going to print the score. So this is what we observe on this given data. So if I apply cross validation score, so here the cross validation score is given by this value, which is given by the negative. Okay, so I have printed the root mean squared error at each iteration. Next, what I'll do is I'll just go ahead and directly perform the fit on my model. So I would say model.fit xtrain comma ytrain. Okay, instead of using the cross validation score. So I'll just perform the fit as it is, and if I display its coefficients, so this is how the model coefficients would look like. And if I display the intercept, this is how the value of my intercept would look like. We'll just go ahead and generate the prediction. So ypred is equal to model.predict on my xtest. Now once this is done, we'll calculate the R2 score. So ytest comma ypred. So the R2 score is 0.9794. Now that's amazing. Now the final question was, we have to plot the predicted profit and the actual profit from the test data with respect to the R&D month. So I'll write it like this: plt.plot from my xtest. I'm going to extract the column of R&D spend. Okay, and I'm going to plot the value of ypred, and I'll use the color of blue color, and the label is predicted data, and plt.plot, and this time it is xtrain. Okay, and this is actually my ytest. Okay, xtest with ytest, and I'll use the color as red, and I'll mention the label as given data. I would say plt.legend, plt.show. Before that, we'll also have to import this pyplot module. import matplotlib.pyplot as PLT. So this is how the given data and the predicted data would look like. So we can clearly observe that it's almost coinciding. The given data and the predicted data both are coinciding to each other. That means my predictions are actually closer to my given data. Alright team, so with this we come to the end of this video. As we progress in our upcoming video journey, we are going to get started with a new topic, that is logistic regression. So I'll see you in the next video.